Hi guys. So I'm sure you're missing Mrs. Mumford and I terribly, but this last section in chapter 7 talks about what's called a base E or a natural log. So before I get there, let's look at these first three. So what is the base of each log? Hopefully you can look at A there and know that this is base 3. Hopefully you can look at B and know that it's base 2. And think about C for a second. When there's no visible base, like those are the kind that our calculator uses, what base did we set? Hopefully you remember that this is base 10. Now, those are the logs we've been dealing with for the past week and a half. Okay, there's also what you see next. A special logarithm exists called a natural logarithm. Its abbreviation is ln. I don't know why it's not NL, but it's ln. The base for a natural log is called base E. So log base E is the same thing as ln. Again, the special abbreviation is ln. And what it says there, ln is the inverse of e raised to a power. So first of all, that's a lot of information, and I'm sure you're thinking, what the heck is e? So think of it like this. Back in early middle school, late elementary school, you learned about pi. Pi was an irrational number that went on forever. It was 3.14159, and it kept going. E is also an irrational number. E is approximately 2 point, sorry, that's my clock at my house. I'll wait till it's done. Okay, E is approximately 2.718, and it keeps going from there. Now, when do you use E? Because when you learned pi, the reason why you learned it is for circles, for things doing with circumference, area, everything was perimeter with circles. So in terms of E, E is a number that's used in a lot of scientific applications. So for instance, engineering, lots of sciences, if you're going on to calculus or doing anything that needs calculus, you will use E a lot. So at this point, what you need to know is all the properties that we already know apply to natural logarithms. The other thing you should know, hopefully you have a calculator, but on your calculator, below log, next to the number 4, there's a button called ln. So that is the button we will be using when we're dealing with things with natural logs. Okay, so it says evaluate natural logs. Use your calculator to find the answer. These are pretty straightforward, cut and dry. So you go to your calculator for the first one. ln e to the negative 4. Okay, so you hit that ln button is next to the 4. Now, to get e is in two places. E is either in yellow above the ln. There is also an E above the division sign. Well, when do you use which one? Well, if you notice the one above the ln, it says e to the x. So if your e has an exponent, I would use that one. And since our e does, I would do that. So I would say second ln, and then type in that negative 4. And ln of e to the negative 4 is just negative 4. Now back to my calculator for a second. If I'm using e that doesn't have an exponent, which we will later and we'll see that, then I would probably use the one that's above the division sign. Okay, same thing for the next one, ln of 1, just type it in, ln of 1. You get 0. Okay, and we can keep going. E to the ln of 7, so I go back to my calculator. I hit E first, so second ln, and then I type in ln of 7. The answer is just 7. Okay, so this basic evaluating, these basic plugins are just as easy as when we started normal, regular logs with other numeric bases. So I'm going to pause this for a second. You type in D and E. Okay, so hopefully you got 5 for D and 10 for E. No big deal, pretty easy. Now, in terms of these equations at the bottom, we are going to treat ln just like we treated log, meaning all the properties apply. So when I see something, an equation like this, a natural log equation, the first thing I want to do is try to apply properties. There are no exponents in front, so I can't do that, but I can condense these two logs on the left. There's subtraction there, that means division. So I have the ln of x plus 1 over 7 equals ln of 3. Okay, at this point, it's going to be one of our two log cases. Either it's a cancel or a rewrite. We have a natural log on both sides, so we're going to cancel. I have x plus 1 over 7 equals 3. To get rid of that fraction, I multiply both sides by 7. subtract 1, and hopefully we get that x is 20. Easy. Nothing different than what we had been doing. It's just a different abbreviation. It says ln instead of log. That's it. Okay, very similar over here. Look for powers first. There are no numbers in front of these logs, so there are no powers. So that means I need to combine them with my properties. It says addition. Addition means multiply. So I have the ln of 20x squared equals ln of 5. Again, very similar to last time. Look at the situation. Is this a cancel or a rewrite? Well, I have one ln on both sides. They cancel. So I get 20x squared equals 5. Now I know you see that x squared, but don't square root it first. First thing you have to do is get rid of 20. So subtract 20 from, divide 20. So you get x squared equals 0.25. Or 1/4. If you wrote it as 1/4, that would be totally fine too. And then you take the square root, and your x value should be 0.5. Like I said, guys, right now we're pretty good. I mean, this is the same properties we were using, just with a different abbreviation in front. Okay, now if you look at C and D on the bottom, they're only slightly different in the fact that these are no longer log or natural log equations. These are exponentials. So we're going to do what we did last time, or what we did yesterday, meaning we're going to take this exponential piece and get it by itself. So in this case, I have to subtract 10 from both sides. So I have e to the b plus 3 equals 17. Now at this point, I can rewrite this, okay? Meaning, the only way to break down this exponential is to rewrite it. So this looks like log base e of 17 equals b plus 3. Okay, well we said way back at the top of these notes, log base e is the same thing as ln. This is the same thing as ln of 17 equals b plus 3. Okay, well, we go to our calculator, we find out what the ln of 17 is. That happens to be still doing 4 decimal places. Oh shoot. 2.8332. So 2.8332. Now to get b by itself, I'm going to just subtract 3 from both sides. So if I do that, I end up with b equals a negative 0.1668. So the only catch here is you have to remember that when you see log base e, it's the same thing as ln. Okay, and very similar with d. So my exponential piece is this e to the p minus 2, but it's not by itself. So my first job is to add 2 to both sides. So I have negative 8 e to the p minus 2 equals negative 69. Divide by negative 8. So e to the p minus 2 equals, give me a second, 8.625. Now I'm at the point where the exponential is isolated, so I'm ready for this rewrite. The base is e. So log base e of 8.625 equals p minus 2. We know log base e is the same thing as ln. So if any of you are thinking, can I just jump to ln instead of taking that additional step of writing log base e first? You can. I'm just trying to connect it a little bit to what we did yesterday. So again, at this point, I need my calculator. I need to find out what the ln of 8.625 actually is. That's 2.1547. So I have 2.1547. And then to get p by itself, I add 2 to both sides. So we should end up with 4.1547. Okay? Now, flip over to the back for me. Now, on the back, there are some practice problems. I want to do number 1 with you because on the front, there was no examples like number 1, and then I want you to pause the video and try these. Okay, so with number 1, again, my first job is to say, okay, are there any exponents? There are not. So I'm going to combine these two by the fact that there's subtraction there. Subtraction means divide. So I have ln of 6 over x minus 10 equals 2. Okay, now in the 2 examples we did on the front, we had an ln on both sides. This was a canceling thing. This is not a canceling thing. This is a rewrite. So the question that you have to know is what base goes with ln. The base that goes with ln is e. So when I rewrite this, this becomes e squared equals 6 times x minus 10. Well, e squared is just something I need my calculator for. So if I go to e squared, it tells me that's roughly 7.3891. So I have 7.3891. Okay, so then, just like before, I have to multiply both sides by x minus 10. On the right, I just have 6. Those guys cancel. On the left, I have to distribute, so I have to say 7.3891x minus 73.891. Run out of room. Okay, then I have to keep solving from there. So my next step is to add 73.891 to both sides. So if I take 6 plus 73.891, I have 7.3891x equals 79. I'm running out of room. I'm so sorry. 0.891. And then divide both sides by that 7.3 stuff. And I should end up with x equals 10.8120. Okay, so take a few seconds, pause the video, and practice it, and then you can bring it back in. Alright guys, so here are the answers I got. Hopefully you match up with me. If you look at number 2, when you combine it using properties, it ended up ultimately turning into quadratic. So I had to use the quadratic formula, and I got 1 and negative 19. If you look at number 3, this is another one that became a rewrite. There was only one natural log, so the base was e, so I had to rewrite that and go from there. Okay, if you look at 4, I had to first get e to the n minus 9 by itself. Then I can rewrite this. Again, if you're not writing this step right here, this line that says log e of 29.5 equals n minus 9, that's fine. If you jump right to ln, that's okay. 5 had a lot more work. You had to add 3 first and then divide by negative 10 before you could rewrite. I ended up with 2.7918 and then 6. You had to subtract 6 from both sides. Then you could jump to the rewrite. So hopefully this stuff makes sense. Again, the sub has a worksheet for you that you should be able to do. I want you to complete that and turn that in. That's due before the end of the bell. And I will see you guys on Monday.